Hello everyone, my name is Nikki and I currently work at the DataX lab at Berkeley, and I'll be covering the last module for the NLP section, which is learning models. So today in the learning model section, we're going to dive into is specifically NLP examples, since you guys actually covered the learning models and how to test the accuracy and whatnot. So the first example that we're going to go into is spam ham classification. So we're going to look into how to classify emails into a spam or ham category. Then we're going to move on to sentiment analysis, and we'll be going to classify tweets as negative or positive based on the sentiment. And then we're going to be looking at a generative-based medical chatbot. So the first project is spam ham classification, and the dataset that we'll be working with is this, and here's a link to the full project if you guys want to go look more into it and maybe go through it yourself with the code. But you're given an email, and what the training data set has is first it has a 1 if it's spam, or it's 0 if it's ham. And first what the project goes through is text processing, and this is what we learned to do: stemming, removing stop words, removing special characters, in order to increase the accuracy of the prediction when we run the learning model. And the specific feature engineering and text representation that this project decided to use was a bag of words model, which we covered, and then they used a learning model of multinomial naive Bayes to categorize it. And so other class examples where we would go through a process that's very similar to the spam ham email classification is, for example, fake news detection: 1 if it's fake news and 0 if it's not. Text message classification, we can work with multiple categories here. So for example, you could have stop being one of them, and do not reply, or continue to respond. Flower type is another one that you could have multiple categories for, and you could really use this process for anything that can be categorized based on features. So moving on to the second example, which is sentiment analysis. And there's really a lot of different ways to do sentiment analysis, and we go through one way in the project. So say I'm going to be focusing on a different data set and a different way to do it. So what we're working with is a Twitter data set. So we're classifying tweets as having positive, negative, or no sentiment. And so the data set looks like this. And this is where I talked about previously, where it's important to look at the data set previously before you process, so that you can customize your processing, text processing to the data set. For example, in this one, since we're working with tweets, the project utilized regular expressions to remove things like hyperlinks, which are not useful, Twitter handles, hashtags, or the retweet handles. And so this is very specific to this data set, but those specific things like hyperlinks don't really add value in terms of determining whether it has positive, negative sentiment, which is why we removed them. So moving on to the feature engineering aspect. So instead of using the normal ways of perhaps a bag of words model, what specifically for sentiment analysis you can do is calculate numbers based off of subjectivity and polarity scores. So over here you can see that those are things that impact sentiment, right? So what you can do is you can create new columns called subjectivity and polarity, and use functions, built-in functions, to get those numbers. And then what we do for classification, instead of using a normal learning model like linear regression or whatnot, is we calculate it still based on subjectivity and polarity. So if the score is less than 0, we return negative. If it's equal to 0, return neutral, and else we return positive. And so other applications of sentiment analysis is really just any classifications having to do with sentiment or emotion. So other data sets that you can work on this with is Yelp reviews. So are these reviews positive or negative, and what specific words make it positive or negative? Movie reviews is what we go through in the project for this module. And also emails, we can look at the sentiment of emails as well. So moving on to the last project, we'll be looking at a generative-based chatbot. And the difference between a generative-based chatbot compared to a retrieval-based chatbot is that generative models are not based on predefined responses, but actually based on a sequential to sequential neural networks. And for this specific example, we'll be looking at a medical-based chatbot, so therefore the patterns, responses, and tags will be based off of medical responses and what a medical chatbot would need to respond to. So the data set that we're working with has 4 parameters, so tag, patterns, responses, and context. And the tag is just what the patterns and responses fall under. So for example, no answer, the pattern, which is what the user would type into chatbot, would literally be no answer. So, and then the responses, which is what the chatbot would send back to the user, is sorry, I can't understand you, and whatnot. So what the context is there for is if it wants to use the response of a different tag. So if no answer wanted to use the responses of options, context would put into its string options. So as you can see with the tag adverse drug, they're dealing with a medical-based chatbot. And moving on to the processing part, this specific example, they use lemmatizing. They lowered each word and removed duplicates. For feature engineering text representation, they used a bag of words model. And for the learning model, they used a sequential model with 3 layers. And you can look more deeply into the code with the link. And so other applications for this sort of processing is other chatbots. So for example, the data set you could be working with could be something else. For example, if you're working with education, the tags and responses would change to the needs of your chatbot specifically. Another thing would be something example like email word recommendations. So when you're typing things into your email and it guesses what next thing you might want to type or autofills the phrase that you're looking for. And so really any application that has a text output based off of text input. And that is a wrap for the NLP module.